In this video, you'll learn about base R and the tidyverse. By the end of the video, you should know what the tidyverse is and how you use it in R, whether or not the tidyverse is a requirement for data science in R, how to distinguish base R from the tidyverse, and why we use the tidyverse in this class. So before we get into the tidyverse, I'd like to talk a little bit about the history of R. R's been around for a very long time. It initially appeared in 1993, the first major release was in 2000. It's an implementation of the S programming language, which had been around for a long time, with some new additions. The original version of R had substantial data processing capability, but R has been continuously improved over this time. And there's now a large ecosystem of R packages, and it continues to grow and improve over time. Throughout its history, R has attempted to maintain backwards compatibility. And what this means is programs written for old versions of R and older R packages will generally continue to work even as the ecosystem and R itself evolves. But this has implications. As the R ecosystem has evolved, people come up with new and better ways of doing things. New packages might be released that re-implement old functionality, so it's faster, easier to use. It can handle new types of data. It takes advantage of modern computer hardware. Or maybe it fixes problems that original versions of the package didn't anticipate coming up down the road. On top of this, R is open source software. The packages are developed by many people with really no coordination between them. This can lead to inconsistencies in how similar functionality is implemented across different packages. Often that means you need to read the manual for every package before you start using the tools that are inside that package. So this is where we come to the tidyverse. The tidyverse is a project that's meant to address many of these problems. It's a collection of packages as opposed to just a single package, but you load them with a single library command. What they do is they re-implement much of the original functionality in what I'll call base R, or the original version of R. In contrast to base R, the tidyverse has very consistent behavior across every one of the functions and tools inside the tidyverse. It's focused on high performance on modern computing hardware. The tidyverse has very well-written documentation, which was a shortcoming of many of the older legacy base R functions. And it also focuses on legible, easy-to-use code, which is really important for transparency and reproducibility. So how can you use the tidyverse? You should have already installed the tidyverse in your system using the install packages command. Any script that you want to use the tidyverse, you should start it out with the library function, calling library with tidyverse in parentheses. This is going to load many packages at once, so it might take a few seconds on your computer. In this class, I'm going to focus on solving problems using the tidyverse as opposed to methods that exist in base R. The fact is, everything that I show you using the tidyverse in this class can be done other ways in R. The tidyverse hasn't even been around that long. Version 1.0 was released in 2016, and it's continually evolving over this time. So what this means is many books and forum posts that you might read where people are asking you to solve problems for them in R frequently take the base R approach as opposed to the tidyverse approach, just because the tidyverse is relatively newer. This can pose a problem for you if you're searching for help online, particularly for people who are new to the tidyverse, because they have a hard time distinguishing it from base R. The nice thing is the tidyverse has a standardized set of naming conventions. So functions in the tidyverse are always going to use the underscore between words. So for example, there's a function called readCSV in the tidyverse, and the word read is separated from the letter CSV by an underscore. There's an analogous function in base R, but it uses a period between words. That function in base R is called read.csv. So if you see functions that have dots in the names as opposed to underscores, they're probably from base R, and there's likely an improved version available in the tidyverse. Additionally, when you're using the tidyverse, you're generally going to use the pipe to chain commands together. I'll cover this extensively when we get to this section of the course, but the pipe is a greater than sign between two percent signs. In base R, you don't use the pipe to chain commands together, so the syntax gets really complicated and messy. There's a couple of other things that you'll almost never see when people are using the tidyverse. The first is that referencing column names will never happen with the $sign. This is a base R feature. Likewise, there's a lot of double bracket notation where there's stuff inside two sets of matching brackets. This almost never occurs in the tidyverse. If you see either of these, what you're looking at is probably code designed for base R, and there's likely a better way to do it in the tidyverse. So in this class, I'm going to focus on using the tidyverse in R and RStudio to do tasks in data science. Everything in this class will be tidyverse first, and I expect you to use tidyverse methods in all of the deliverables in this course. So why is it that I require you to use the tidyverse in this course? There's many reasons. First of all, it's easier for you. The implementation of the tidyverse is very consistent. As you learn how to use one function, it actually teaches you how to use many of the other functions in the tidyverse because they all behave in similar ways, they take similar arguments, and they're specified in similar ways. Base R functions are frequently all over the place. They've been growing up with R since 1993. Many people wrote them, they're uncoordinated, and so you always have to read the manual before you use them just to remember how they work. And in some ways, if you don't read the manual, they might behave in ways that you don't expect. This is really often a source of frustration for students who search for solutions on the internet, copy them, and they don't take the time to understand them, not realizing that they're using base R functions as opposed to tidyverse functions, and they behave in ways they don't expect. The fact is, things will be easier if you consistently use the tidyverse in this class, simply because it was designed to be clear and easy to use. Another reason I expect you to use the tidyverse in this class is because it was designed with the core principles of data science in mind. These are reproducibility and transparency. It's my opinion that the tidyverse is a best practice for doing data science in R, but it's not just my opinion. Lots of data scientists are implementing R code using the tidyverse simply because it enhances the reproducibility and transparency of their code. The last reason I require you to use the tidyverse in this class is this is the way things work in the real world. Not that everyone uses the tidyverse, but if you go and you work as a data scientist or you do any programming for an organization, the team is going to have a set of standards, and the programmers are expected to adhere to those standards. So what they're going to do is they're going to tell you the software packages that you can use, the programming languages that you can use, and the specific ways you should write and implement computer code. This is essential for transparency. People in the organization need to understand the work that other people have done, simply because people might move around in the organization, they might leave, go on to other jobs, or they might be assigned to other tasks. And using a set of standards for writing your software makes it easier for everyone to understand what's going on. This is, at its core, transparency. That doesn't mean that organizations are completely inflexible. As you go out into the real world, if you have a good reason to go against the standards, you should definitely make the case for that with whoever's in charge of setting those standards and clear it ahead of time. Often you can find that organizations are flexible if they see that there's a better way to do things.